and we were talking about it being the opposite. When we think about opposites, the thing is with opposites is that they usually undo each other, okay? If you are thinking of operations, add, subtract, multiply, divide. So if we think of things that undo each other, Allison, what might you think of being opposites or inverses?
Positive and negative.
Okay, but let's go with operations. So if we add, the opposite would be, or the inverse is to?
Subtract.
Subtract. And we could go back and forth either way, right? So add and subtract. We can often think of multiplying with, what would the inverse be? Divide. Division. How about if I square something? What's the inverse of squaring? Taking the square root. Okay. So there's a short video that we are going to watch with this, and then we're going to talk about on the bottom that inverse function. Okay. So we're going to watch this. Oh, let me get my speaker. Or my.
People building new homes often buy the lot first, then work with a builder to design their home. But building a house from scratch can be expensive, and the bigger the house, the more it costs. In this new neighborhood, the builder has figured out that it costs $125 per square foot to build a home. In addition, each lot in the neighborhood costs $85,000. We can build a function that will represent the total cost of a new home in the neighborhood with a given number of square feet. Let's call this the cost function C, noted with a capital C, and use lowercase a for the area in square feet. So C of A equals
function notation, if we're looking at
85 times A. A times 125 is the construction cost, and 85,000 is the cost of the lot.
Could you tell me, if I was looking at this, could you tell me what the domain and range is at this point? Can we figure that out if we're looking at an equation? We should be able to. You're going to have to do that on the test, right? You have to tell me, going back to that B2, what's the domain and range of the function. So making sure as you're watching this and you're thinking about all these questions as we finish this unit, what's your domain and range?
Now, what if a prospective customer wants a new home but won't spend more than $450,000? How can we figure out the maximum size house this customer can afford? The cost function gives the cost of a home as a function of area. Now we want to figure out area in square feet based on cost. Algebraically, it's simple. Solve the equation for A, the square feet. First, substitute a lowercase c for C of A to represent the cost as a variable.
We'll kind of do this, but we're going to do it just a little differently.
Finally, divide both sides by 125. This now gives us area as a function of cost. We can call this function the area function, noted with a capital A. The cost function and the area function are inverses. C of A will tell us the cost of a home with a given area, while A of C will give us the area for a given cost. Inverse functions are represented like this, with a superscript of -1 on the function name.
So this -1, because we're talking about an inverse, you need to use that button on your calculator. There's a calculator button on your calculator that has that -1. It's usually x to the -1. And that is usually telling us inverse, okay? And what that really just means is reciprocal, okay, of a number. So like if you put 4 on your calculator and you hit that button, you should get 0.25. If you put in 2 and you hit that button, you should get 0.5. But this is going to be the inverse function. That's just the inverse of a number, which is really the reciprocal.
We can use any variable to represent the input value for the area or the cost. When working with functions, x is usually used to represent input values. To find the area of a house that costs $450,000, substitute $450,000 for x in the area function and compute. Our final answer is that with $450,000, our customer can build a 2,920 square foot house. Remember, to find the inverse of any function, solve for its input variable. This gives you a new function as it relates to the output of the original function.
So if we are looking at this is really important as we start looking at this. So what is an inverse function? Inverse function is when the domain and the range trade places. All elements of the domain become part of the range, and all elements of the range become the domain. So if we have this function f of x where we have 0, 3, 1, 4, 2, 5. So we're going to start with our original function with that 0, 1, and 2 are our domain. The inverse is when we flip those around, right? So now it's 3, 0, 4, 1, 5, 2. And what they are talking about is, will it always be a function if we are looking at this first one? Is this first one a function? Is each one of ours has a unique output? Yes. How about this one? Is the inverse a function if we are looking at that? Yes. So this is that button on your calculator most of you found, x to the negative 1. Okay? It might be this on your calculator. You might see this button, 1 over x. That's the inverse function. So if you don't have x to the negative 1, you might have 1 over x. Okay? And let's see. I am going to have to look at yours. It might be under one of the buttons, like under the math button, for those of you that calculator. It might be under the math.
I think it's just there you go.
Yep, you can go 5 to the negative 1 on yours. So you want to just make sure that those of you that have that calculator. But I just wanted you to make sure that if you would put in 2, you should get 0.5. If I would put in 0.5, the inverse should be 2. If I put in 4, I should get 0.25. That's what that is doing, is just taking the reciprocal. So I just wanted you to make sure you know that that button, it's really nice, like when you have a big problem and you wanted to divide everything by some number and you get for an answer, to just hit that reciprocal button, because that is then multiplying by its reciprocal. So that's what that button is, that's our inverse. So if we are graphing two functions, it says, if we graph function 1, so we put 0, 1, we put 1, 2, we put 3, 2. Of course, we would always have ordered pairs, right? So we have parentheses around these. Okay, so please put parentheses around, because when we're talking about an ordered pair, you want to have the parentheses, or else I'm marking it wrong for you. So the inverse function, is the inverse of this one also a function? So the easiest way, is the first one a function? Yes. Passes the vertical line test. Is the second one? No. So if we are looking at this and the question is the inverse a function? In this case, no. Why? Did it pass the vertical line test? So just because the original one is a function does not mean that our new inverse is not a function. Now, your homework, these are some examples of some functions, okay? If I was looking at this one, this might be my f of x up here. This one would be the inverse. This might be my parabola, f of x, where I plug those numbers in. This one down here that curves this way, this is my inverse. Okay? So, are both of these two going to be functions? The function and the inverse? They're both functions, right? Each input has one output. Down here, the function is an input, but if I look at the inverse, this one is not going to be a function. So this f of x is a function. The inverse of x, that's what that is called when you say that. The inverse of function f, in this case, is not. Would both of these two be functions, the blue and the red one? Yeah, they're both going to be functions as we look at those. All right, so this is what you have to do in your homework. You have questions 1 to 12, and it's going to give you a function, and this is what they were talking about in that video. We have this function f of x. The first thing you are going to do is you're going to rewrite it, and instead of f of x, you're going to replace the f of x with a y. So the first step is you'll go y equals negative 2x plus 4. Everything else stayed the same. The first thing you did was you replaced the f of x with a y. Next thing you're going to do is you're going to switch the x and y place. So you now put an x here and you put a y here. And now you're just solving for y, like when we did literal equations. Okay? So what do we have to do to solve for y? If we're solving for y, our first step was subtract 4 from both sides. So I'm going to take and subtract 4 on both sides. I get x minus 4 equals negative 2y. I am then going to divide everything by negative 2. I get negative 1/2, so I'm dividing, this is a 1 in front of that x, so negative 1/2 x. Negative 4 divided by negative 2 becomes a plus 2. Here's how you will write your answer at the end of the problem. You'll start with writing this. This will be my final answer. You'll put f to the negative 1 times x. So the inverse function of f is equal to 1/2 plus 2. There is at least one of these on your test on Monday. Okay? So we're going to do these two together. First thing we're going to do is rewrite the equation with y equals 4x minus 8. Next step, change the y to an x, change the x to a y. You are now going to solve for y. So you're really just changing the places. So now we add 8 to both sides. If I do that, Kaylin, I'm going to have what on the left side? X plus 8. Now, I don't even want to put 1x plus 8. It's going to be equal to 4y. Lauren, I'm solving for y. What do I want to do next?
Divide by 4.
Divide by 4. And I'm dividing everything by 4. And I know some of you like doing that one division line, but I want these both simplified. So I like to do them all like this. So y is equal aj to 1/4 x plus 2. I'm leaving my answer as I look at this. My answer is going to be inverse of my function x. So I write f of x equals, and then I just write this equation, and I'm done. That's my answer. That's what you're doing. You're just writing the inverse function. And if I would graph both of these, this one we're going to learn in that next unit has a slope of 4, which means it's going up 4 and over 1. This one has a slope of 1/4. It's much flatter. Okay? So when we look at that as we get into our slope intercept. So now we have this one. So start it out the same way. First step, change it to y equals. When you do yours on your paper, show me all of the steps. Okay? Those of you that like to skip steps, don't do it. Especially as you're starting it. So, as I'm starting, next step, Kylie, I got the first one, then I'm going to do what? Not yet. I got to change the variables around, right? So, tell me what I should write down.
X equals negative 3/4 y plus 3.
Negative 3/4 y plus 3. Now, we're going to subtract 3. So if I'm writing that, roots, I'm going to have what?
X minus 3 equals negative 3/4 y.
So a lot of you, when we have that 1x minus 3 equals negative 3/4 y, I need to get rid of negative 3/4. Grace, what should I multiply every single thing by to get rid of that?
3/4.
Not 3/4. Someone else. What do you think, Sam? 4/3. Not quite, but close. Why? Why can't I use 4/3? It's really close, but it's not quite right. Because it does have to be negative. So I am going to multiply every single one of these by a negative 4/3. So negative 4/3 times 1, negative 4/3 times the 3, and on this side, yes, I multiply by a negative 4/3. Okay? What's nice here is I'm leaving it with a y. Negative times negative. If I went to multiply by a negative, I would have had a negative y. I am not trying to find negative y. My y always has to be positive. So negative 4/3 times 1. Addison, what am I going to end up with? If I multiply these two together.
Negative 4/3.
Negative 4/3 x Keep going.
minus 12 thirds.
All right, now,
Negative 12 thirds.
negative 12 thirds. And if I'm looking at this and I like simplifying beforehand, what do I notice about 3 over 3? That's the same as 1, right? So I have a negative times a negative, so I have to change it to a positive, and I'm going to have a positive 4. And I could have had what Addison was telling us, which what she said was that she would have had negative 4 thirds x minus a negative 12 over 3, and I agree with that. But you got to simplify this in the answer, so if you can simplify here, do that. I'm going to write my answer. How do I need to write the answer? Noah, tell us. F negative 1? Yep, keep going. So the x equals? The answers for the odds are in the back. You want to have your answer left like this, so as you're doing the problem, okay? Anyone know they are gone tomorrow and needs to get the worksheet for that you're getting tomorrow in class? Okay. So tomorrow you're going to get the review worksheet. So tonight you have these 12 questions to do. You are only doing 1 through 12. If you really feel like you want more practice on this, by all means, go through 18. You don't need to, okay? 1 to 12, you should be good if you've done those. Make sure you're checking, and it would be great if tomorrow when you come in, again, if you have questions on this, you can stop in and check with Mrs. Lee. I talked to her earlier and just let her know that some of you might be coming in if you're not sure about some of them. When you take the test on Monday, we will turn in this assignment B7, and you'll turn in your review, okay? So, make sure, as you're doing those, so you got about 6 minutes as you're starting out. You should probably have maybe the first 3 done in that time. For sure, the first 2, if not more. So start, I'll leave this up here. Keep your notes out if that helps you so that you can see exactly what you are doing, okay?